naman tayong bagong project. Ano na naman yan? Ha? Meron tayong bagong project. Ito ay tinatawag na remote control using 4017 IC. Yun, 4017 IC. Ano namang klaseng remote yun? Bak, testingin natin. Lagyan natin ang supply 5 volts. Okay? Meron tayong power LED. So, ibig sabihin yan, bakit siya? Yun. On ka agad. Okay? On siya. Meron tayong power LED. Meron tayong infrared sensor receiver. BS 1838. And then meron tayong output LED at may mga resistor at kapasitor. Merong 4017 IC. Paano naman gumana yan? Paano nag-remote control niya? Etong kailangan natin, remote. Pag pinindot ko yan, diba? Wireless. Sa tuwing pinipindot ko yung remote, umiilaw yung input LED sa board ng ating sensor, infrared sensor receiver. Yun. Yan umiilaw yung pula. Ang range niya ay 7 meters. Ito pa ang matindi rito. Pwede mo siyang gamitin kahit anong button. Basta pindutin mo yung remote, umiilaw siya at nag-o-off. Line of sight. Ang isa pa niyan, eto pa, ibang klaseng remote. Pwede rin siya. Kahit anong button. Ito, ibang remote din. Uy, ba't ayaw? Walang battery. Yan. Diba? Diba pwede siya kahit anong remote? Basta remote ng pan-TV, yung may IR. IR, infrared transmitter. Meron remote ng TV. Ito rin. Eto na. Ito ay remote ng signal. Diba? Medyo mahina yung battery, pero okay pa rin. Remote control ng LED strips. Diba? Kahit saan pindot mo, on off siya. Yan ang bago nating project. Remote control. project, we have this figure 1 BS1838B infrared sensor receiver. So this is the sensor we use in our project. Let us see the actual module. This is the actual module. So this is the main receiver. This is a receiver sensor for the remote control. We have the pin out, negative, positive, and then signal. Signal is the output. Connected is the LED, and then the resistor. Okay, so we have the LED resistor connected to the signal and then to the ground. And we also have the circuit diagram of our project. So this is the circuit diagram. Figure 2 infrared remote control receiver using 4017. We are constructing this module as an infrared remote control receiver. This is a receiver circuit. Our transmitter is the, what is the transmitter? The remote control itself. So this is the remote control transmitter, and then this whole module is the receiver. For our module, we are using 5-volt supply. We have this power LED blue to make sure that our circuit is on. Power indicator 6.8K current limiting resistor for the blue LED. So blue LED is the power LED. To make sure or to indicate that the circuit is on, we have this receiver that is now the infrared receiver. Okay, this one. This is the receiver connected to the ground and with a positive connected to the 5 volts. And we have this S, that is the output of the receiver. So when we press or we use the remote control, it transmits the signal and it received by the receiver. So this one is transmitter, the remote control, and this one is the receiver. Okay, it receives the signal from the remote control. That's why we need this module. So here we have this transistor 2N3906. This is a PNP type transistor, emitter base collector. The emitter is connected to the 10K, okay, and connected to the 5 volts. So this emitter will switch on this transistor because the current flows into the 10K, into the emitter, and then to the base, switching this transistor on, and then to the ground. Before the ground, we have this capacitor, 100 microfarad, 16 volts, and then to the output. So it means our current enters into the sensor with this initial state of the circuit. Current flows into the emitter, switching this transistor on to the sensor and also to the capacitor. What's the use of this capacitor? This is a coupling capacitor to stabilize the circuit because the signal emitted by this transmitter is an oscillating signal. It oscillates as oscillating signal with a frequency of it has a frequency of 38 kilohertz. The signal emitted by the transmitter, 38 kilohertz, oscillating a series of PWM. So that's the signal emitted by this remote control transmitter and to be received by this receiver. So initially, this circuit is on because it's directly connected to the sensor with the coupling capacitor, and since PNP transistor is on, current flows into the emitter to the collector and injecting a current to the 4017 IC. What is the purpose of this 4017 IC? What is this? This is a decade counter. Okay? The main purpose of this IC is to serve as a latch switch or toggle switch to the circuit. So initially, it injects a current to the 4017. And what's the use of this capacitor? Coupling capacitor here, or the coupling capacitor, to make sure that the input of this pin number 14, which is the clock, this is the clock input, will not bounce. So this is a debouncing capacitor, so that it will have a smooth current that flows into the pin number 14. So the purpose of the capacitor here is to prevent debouncing of the signal. What I mean by debouncing is sometimes it produces a stray signal. Okay, and what's the purpose of this 100K resistor? That it serves as the pull-up resistor. If we did not pull up this 4017 IC, it will not function properly. So we need a pull-up resistor to make sure that this IC is on. Okay, and then pin number 16 is the power supply of the 4017. Pin number 8, ground. Pin number 13 is clock inhibit. What is the use of the pin number 13? To make sure that the clock, to enable the clock input 14 if we put it to the ground, if we ground it. Okay, and then pin number 3 is the output with the yellow LED, current limiting resistor of 120 ohms. Pin number 4 is also an output, but since we are using this decade counter, it serves as a toggle. This is the one that is toggling or latching, because it reset the circuit. Okay, once we press the switch of the remote, will receive by the receiver, and now since we are using now the remote, the current now flows outside the sensor. Before it is inside the sensor, now it is outside, and making this transistor to turn off. When this is turning off, now the current flows into the pin number 14, injecting a current to the pin number 14 with the use of this debouncing capacitor. and making this pin number 3 to turn on. So this pin number 3 we have now this current from pin number 3 that will make this LED to turn on. This is a decade counter. It has also called, it is also called a sequencer. So every time we press the switch, it has a sequence to turn on, to which what output pin will going to be turned on. For example, 3, 2, 4. When we press the remote control, pin number 3 will on. Supposedly we have pin number 2, but here we do not have the pin number 2. If we put pin number 2, pin number 2 will be off, and another pin number 4 will be off. This is a sequencer. So when we press again the button, this now will become off, and pin number 2 will become on. Pin number 4 on, off. And then reaching the pin number 4, it will reset the circuit. So that's why the pin number 3 will turn on and off, because of the pin number 4 is connected to pin number 15. That will make the circuit to reset. Resetting it to 0, 1, 1, 0, or making this pin number 3 to turn on and off due to the sequence of turning on and off of the output side of the 4017 IC. Okay, once we inject another current, it will on, off, because of it will make this pin number 3 to turn on, off, to turn on, off, because of the pin number 4 is connected to the reset pin. Okay? That is the function of the module. Okay, in summary, this serves as a latch switch. In short, this serves as a latch switch. What's the use of transistor? This serves as a triggering device for the clock, or triggering device for the IC. A triggering device that injects current on and off, on and off.